Welcome. My name is Larry Pearson, Vice President of Marketing at Impetus Technologies, and I'll be your host for today's webinar on the topic of keys to ensuring airtight security in the cloud. For those of you who may not be familiar with Impetus, we are a U.S. corporation. We're headquartered in the heart of Silicon Valley, and we distinguish ourselves in a couple of ways. The first is that we specialize on what I call all things data. And we help large corporations achieve what is commonly referred to as a single source of truth, and what actually inspired this mission statement that you see here on your screen now. Secondly, we bring a deep combination of skills, methodologies, and services, but we also bring automation tooling to assist companies in wherever they may be in the end-to-end journey, from strategy all the way through to DevOps, and all the different steps in between to help you address wherever you may be in that journey toward a modern data architecture, which in today's world very often involves a cloud or some cloud strategy. Let's take a look now at the agenda for today's session. We'll start by framing the current state of this topic regarding data security in the cloud, talk about some of the risks that are involved with that, the impact of those risks, some cloud security models, and then a cloud security approach, and lastly, some recommendations and solution approaches regarding methodology, approach, and best practices. And lastly, as I said, we will have time set aside to answer your questions, and look forward to doing that. Another way we make this an interactive experience for you is by having a couple of polls. You should see a poll opening on your screen right now. That poll says, what area of cloud security is the most crucial for you? There's 5 options listed there: access and authorization, application processing, data storage, data privacy, and cloud infrastructure. And this poll will actually stay open for another 15 minutes or so. You can answer it at any time. And after that, I'll be back on the air here to share the results of that with you. And it's always a very interesting dimension that we include here as a way to make this interactive. Let me take a minute and introduce my colleagues here today. The first is Shadish Bali. Shadish is a Director of Engineering here at Impetus. He has more than 20 years of industry experience and also manages our DevOps practice. He's been involved in various DevOps initiatives with a large number of enterprises, and focusing on cloud, big data, CI/CD, agile enablement, and is also a certified SAFe 5.0 program consultant. With him also today is Mustafa Batteriwala. Mustafa is a senior DevOps architect. He has more than 16 years of industry experience, primarily in cloud, DevOps, containerization, and has been directly involved designing and operationalizing cloud solutions with our clients, with a special focus on security, performance, scalability, and elasticity. So to get us started here on our webinar today, let me introduce Shadish Bali.
Thanks, Larry, and good morning, everyone. So, as we all are aware that cloud computing has really gone mainstream in last couple of years and has become a key pillar for enterprise technology. Cloud has transformed the way organizations operate and deliver services to their customers. And as consumers, it is imperative for us to make these cloud services enterprise ready. Now, one of the key challenges that organizations are facing today is to secure these cloud services. Customer has to deal with heterogeneity on various cloud technologies, different environments, whether it is hybrid or multi-cloud environment, adherence to federal and organization policies, cloud applications in the form of workloads, and last but not the least, the data which is flowing throughout the environment. Now, although cloud providers are continuing to offer security measures better than ever before, it is the responsibility of the customer to secure the cloud ecosystem. As per Gartner, by 2023, most of the security compromises will be due to companies' negligence and not due to cloud providers. It is expected that the cloud security market size will be over, $10 billion by that time. One of the surveys, indicated that 93% of the organizations are moderate to extremely concerned about cloud security. And lastly, the unprecedented situation that we all are in the last couple of months has made remote working as new normal, as you know, and securing cloud assets has become critical than ever before. Let's begin, looking into some of the security risks and their impact. Now, some of these risks are from conventional world and are also relevant from a cloud perspective. There's a need to, sufficiently understand identity of users, their credentials, their keys to avoid unauthorized access. We all are aware of consequences of misuse of such credentials and improper access control. This requires a discipline that enables right individuals to access right resources at right time, of course, with right reasons. Malicious attack results in hackers gaining access to cloud accounts to deliver an undesired outcome. Some of the common carriers we used here for these attacks are definitely emails, viruses, chat windows, web pages, attachments, and etc. And moreover, the cloud model provides more computational power to such denial of service attacks, as more number of machines will be available for compromise the large number of systems. You might have heard of, some years ago, Sony PlayStation network was almost down for a day due to one such web attack. In case of a data breach, hackers would have access to personal files and intellectual property. A couple of years ago, LinkedIn experienced a massive data breach. I think they had around 150 million account credentials. Those were compromised. One of the largest credit rating company in United States also had a breach for their sensitive personal data for, again, like more than 100 million consumers. So there is definitely a need to secure sensitive data and focus on data lineage. Data loss is, usually harder to predict and even harder to handle. It can cause by either a human error where there's no backup available, or data is modified where we do not have the earlier version of it, or the storage medium which is provided by the cloud is unreliable. Data integrity is all about overall accuracy, reliability, completeness, and consistency of data. The risks here are associated with unreliable and inaccurate data sets, non-compliance with regulations, healthcare regulations, GDPR, and other such regulations. This can even put enterprises to a risk. One of the often overlooked risks is maintaining availability. Now, many enterprises think that once things are moved to cloud, their worries will disappear. Once the application and data is moved on cloud, they'll take care of it. But that's not the case. This needs to be mitigated with proper backup strategies, DR and HA strategies. These risks will result into significant impact on the businesses. There was a news about Target store data breach that kept their consumers away during a peak holiday season, resulting in substantial revenue losses. For large enterprises, it means customers moving away from them to their competition. And once an outsider has an access to intellectual property, enterprise may lose their owner's claim on it. Because of these risks, enterprise may land up in contractual issues. For example, a cloud service may maintain a right to share the data with third party, which in turn violates the contract and breaches the agreement that the enterprise has made with the business partner. Now, in a cloud model, organizations can quickly go in a state of non-compliance, and with increasing legislation on data protection, like from GDPR HIPAA, SOX, PCI, PII compliances, company can get into legal issues real quick. To sum it up, the eventual impact is the customer's trust and the enterprise brand image. So one of the questions that I have seen in security requirements discussions with our customers is, who owns what in a cloud environment? There is always a need to clearly understand the ownership of the cloud provider and the ownership of the customer. The division of this responsibility depends on cloud service delivery mechanism and the level of usage by the customer. And this is not static. It varies from each cloud implementation to the other cloud implementation. Even cloud providers have guidelines on shared responsibility models to address this concern. And I would like to create a quick context to understand the security implications better here. Essentially, it starts from the level of abstraction. In the first model here, since cloud provider manages the infrastructure, that is their physical hosting and environment, it becomes the responsibility of the cloud provider. This is referred as infrastructure as a service. For example, an EC2 service. Now, the cloud provider will manage security of its foundational services like storage, compute, database, and networking. And rest all of the above, from operating systems to platform to application and to data, security has to be managed by the customer. In platform as a service model, more responsibility is given to the cloud provider on securing platform components, operating systems, their guest operating systems, where customer continues to manage security for the application and data. Of the three models that are available, software as a service put maximum responsibility on the cloud provider to manage security of everything, except the customer has to secure data and also need to decide how they would want to use this data. The more you go lower down the stack, the customer will have more items to consider from a security perspective. Now, with this brief overview of shared responsibility model, let me hand it over back to Larry. Larry, it's around 15 minutes. Maybe if you got poll results, and let's show that before we move forward. Over to you, Larry.
Sure. Yeah. The poll results should be displayed on your screen here shortly. There we go. And you'll recall that those questions were, which area of cloud security is most crucial for you? And we see here that cloud infrastructure far and away, with 60% of our attendees saying that that is the most important and crucial aspect. We'll cover all of these during today's webinar, but it's interesting to see the importance that all of the questions, challenges, and so forth that are raised by moving to cloud from a more of a legacy environment can raise. So thank you for that. And Mustafa, if you want to jump in now and carry on the conversation.
Thanks, Larry. Good morning, good afternoon, everyone. And thanks, Shirish, for walking us through some of the security risk and the impact. And Larry, looking at the poll results, I'm not surprised. I think infrastructure is the gateway to the cloud environment. And as you said, whenever the cloud deployment starts, enterprise thinks of moving towards the cloud, infrastructure is the first thing that they need to develop and design and implement. And then that is the topmost security concern that we have. And during this, we are going to talk about some of our experiences and best practices on the infrastructure front as well. But before we get deep into the overall security implementation, let's quickly look at that. How do we approach towards the cloud security? And we have implemented some large-scale cloud deployments. And based on that experience, we have come up with an iterative approach that looks at cloud security in a holistic manner. So the first step is defining and establishing your security requirements. The requirements would depend on the nature of business, the organizational strength, the processes involved, the business and the services which are being used. So we need to decide that how many accounts, how many environments we need to have, How do we segregate production and non-production environment? What would be the networking architecture? How the cloud will communicate with external services, on-premise services? What are the firewall policies as well? How the users will access the cloud resources? Will there be an integration with an Active Directory? What kind of policies will be defined? So once we establish the security requirements, we create a security plan, which is a blueprint of the entire security implementation. It captures each and every detail so that different teams are aligned on the overall security implementation. It includes the audit processes, mechanism and frequency of the audit, the keyword password policies, how frequently the credentials will be rotated, what are the possible tools that will be used for implementing the security. And next, we get into a repetitive loop of implementing a security and then analyzing it. Once we implement a security using different tools, configurations, it is not enough. We need to continuously monitor it, identify any gaps and risks which are still left, and then keep on solidifying our security implementation. And we'll look further in our session what are the different kinds of tools that can help us in overall monitoring and analysis. Now with this, let's get into the details of security implementation. There are 4 major areas in cloud that we need to look from a security perspective: infrastructure, platform, application, and authentication. Let's start with infrastructure, and I think the audience voted for this, so probably we'll have a lot of more details in this section. Infrastructure is the lowest layer of cloud. It provides all the basic cloud services like compute, networking, storage. So compute refers to the processing capacity where we can get virtual machines and we can deploy our application, while storage refers to the raw storage of data onto the cloud. Now let's look at some of the best practices in the infrastructure which we recently applied for one of the cloud deployment for an enterprise customer. So this was a first major cloud initiative for the customer, and as enterprises, they were very specific about their overall security. So they wanted to set up their data analytics environment onto the Amazon cloud. So we started with deploying a virtual private cloud for them. Virtual private cloud is nothing but an isolated network in the cloud where all the cloud resources are abstracted and hidden away from the outside world. We also used different methodologies like public-private subnet, firewalls, security groups, network ACLs to make sure that all these cloud resources are abstracted from internet. Thus, they are insulated from outside attacks and malicious intent of hackers. All the infrastructure components, compute instances were in the private subnet. In order to apply patches, download software, they were able to access internet through the NAT and internet gateway, which provides a one-way communication. Moreover, this VPC was connected with the on-premise network using the secured VPN connection. This made sure that only authenticated users from the customer's environment can log in into the cloud and use the application. For the operations team to debug any production issues, we provided a jump server, which is again connected to the customer's VPN. So the teams can log into the jump server and then connect to different master nodes and worker nodes or other utility servers to debug any issues. The database has been an important part of any application. As a best practice, we recommend deploying database in a private subnet, making sure that only the application subnets can connect to the databases. You would also see that we have used availability zones and database replication to make sure that our data and applications are available in terms of any availability zone goes down. Now, let's move on to the other important area, which is the platform. platform provides the processing services for any application. This includes services like Elastic MapReduce, HT Insights, analytics services, and containerization services like Kubernetes engines. Each of these services have their own mechanism to implement security. For example, databases would offer database security in terms of database security groups, multi-deployments, high availability, and firewall restrictions. Similarly, the containerization services would provide mechanism for scanning of images so that none of the images are vulnerable to the virus attacks or the malicious attacks. Now, let's look at one of our reference implementation for securing Elastic MapReduce in Amazon services. We were deploying an AWS-based data lake for one of a financial customer. And as you know, financial industry has many regulations and compliances to follow. As a mandate, the entire data that comes into the cloud, that is processed in the cloud and then again stored in any of the storage, has to be encrypted. Apart from that, we need to make sure that none of the PII data is accessible to any of the unauthenticated users. EMR being at the core of the data processing pipeline, we have to make sure that EMR is secure. It would read data from different sources like the storage services or the block devices where the data is kept. We are using the cloud encryption for storing any data that resides on the storage or the elastic block, which we refer to as encryption at rest. Whenever EMR is talking to any of these services and requesting data, all that happens over an SSL TLS connection. That makes sure that there is no man-in-the-middle attack for any of these communication and data traverses securely to the EMR. But what about processing in the EMR? If somebody gets into an EMR, they can actually access the entire data during processing. So what we do in that case, we can put an entire EMR into a VPC itself and restrict access to the master and worker nodes using the infrastructure security. Apart from that, EMR itself provides a lot of configurations to process and encrypt intermediate data. We can enable configurations like RPC encryption, data transfer protocol, which make sure that all communication happening between the EMR components is secured and none of the sensitive information is outputted into the log files. Also, all the web interfaces provided by Hadoop, like Resource Manager, Node UI, which can be used to get into the log files, which can be used to monitor the metrics. Everything runs on the SSL, making sure that all the communication is secure. Now, let's move to one of the important layers on the application. Application services are serverless frameworks, AI/ML services, business and intelligence services provided by different cloud providers. It includes services like Lambda, Azure Functions, Google Cloud Functions, and other machine learning libraries. With the agile development, applications are developing really fast. Application developers use a lot of third-party libraries, dependencies to speed up their application development. We need to make sure that all the libraries, all the dependencies that the applications are using are properly scanned and doesn't contain any vulnerability issues. For that, we recommend integrating all the scanning and vulnerability testing as part of our CI/CD process. Now, let's look at how we can use cloud tools and secure applications running in the cloud environment. So we were developing one of the learning platforms based on serverless technologies. And serverless provides a lot more challenges to secure the application because there are many triggers for serverless. They can be executed by an API, they can be executed by an SQS event, they can be executed by a storage event. So the scope is pretty large. And the traditional tool still works on an agent-based approach. They are still trying to come up with solutions for serverless applications where there is no server involved. One of the popular services that can be used is Windows Application Firewall. The Windows Application Firewall sits as the front face of the application. It allows us to define multiple rules for detecting threats, IP address whitelisting, preventing SQL injection, and there are a lot of default rules which are provided by the cloud providers. Any request at the HTTP level which goes to the application is first intercepted by the web firewalls. It evaluated against the different rules, and then they are further sent to the CloudFront or the application load balancer, which sends them to the EC2 instances for serving. Now, data is a critical part of any application we develop on cloud. And data has to be kind of secured for many reasons. Because of compliance reasons, because of audit needs, there are decisions that has to be taken on the data. So we need to protect the integrity and the authenticity of the data. There are different mechanisms which we can use for protecting our data. So storage buckets, storage services are one of the popular ways to store data. So we can use at rest mechanism to encrypt each and every data that resides in those buckets or at the storage layer. Apart from that, we can also provide a lot of policies where that data cannot be accessed by any of the unauthorized users. In order to prevent data loss, we can have versioning and we can have multi-factor authentication on operations such as delete, which make sure that these data cannot be deleted easily. Any outside resource, cloud resource, or any external application accessing that data has to use the SSL endpoints, making sure that all the data traverses in a secured manner. Let's look at the fourth area of the cloud security, which is authentication and access control. This applies to each of the three layers that we talked about. There are a lot of services like identity access management services provided by cloud providers that can be used to set up different policies and roles for accessing those resources. Let's look at one of the implementation that how this access control works in case of different services. Each of the cloud resource that we use, so be it storage, be it data warehouse like Redshift or processing like EMR, provide different operations to the end user. As a best practice, we can set policies where we start with providing minimum required access. We provide users the access which they require. If somebody requires access to run a job on an EMR, we only provide a run job access, abstracting any of the other things. Another practice that we recommend is to club similar users into groups. So we can have a group of users. For example, we can have a group of data analysts who need access to S3 bucket. So we can create a group, provide them read-only access to the buckets. Even if there is only one user to begin with, we recommend using groups so that later when there are more number of users, it's easy to manage. We can just add users to a group and we can start using them. These policies can also be used for accessing resources across different accounts. So in a recent implementation, we saw that for an enhanced security, the customer implemented different accounts for different for data processing, data transfer, and data consumption as well. So that made sure that different teams acting on different streams cannot access the data at different tiers as well. So that is also possible using access and authorization mechanism. Now, we earlier talked about in our approach that security monitoring is an important paradigm. And we have seen in a lot of our engagement, this is one of the most ignored ones. Teams set up the security and then leave it up to the existing configuration and tools to save them from any attacks. That's not correct. We need to continuously monitor all the audit logs which are generated in the cloud environment. Who is accessing the resources? What is the purpose of accessing the resources? What are the passwords attempts being made by a user? It helps us, the VPC log flow analysis, the networking logs. All these helps us to come up, analyze and come up with recommendations to solidify our security configuration. Apart from that, there are tools provided by different cloud vendors like the Azure Security Center. Google provides a security command center, and Amazon provides trusted advisor, guard duty inspector, which continuously monitors our cloud resources, who is accessing them, are our keys getting rotated periodically? If there are any keys which have been not been used, let's say in 6 months or a year, all these recommendations are provided by these tools, and then we can use these analysis and fine tune our security implementation. That helps us to make sure that our cloud infrastructure is secured and is secured from any attacks from the outside users. With this, let me kind of call Shirish and ask him, request him to do a quick recap on some of the best practices that we talked about.
Thanks, Mustafa. That was a great overview of some of the examples and assignments that we have worked on. And as we can see, right, I mean, application security, platform security, infrastructure security is itself in a topic, and this can go really, we can go deep in each one of them. What I'm trying to do here is, summarize some of the best practices that we have seen in our experiences, and these are some of the important ones which are common and it should be are recommended, right, that everybody should use this. So, while cloud providers provide excellent service management layer around, infrastructure platform, businesses are responsible, I mean, to protect the confidentiality, integrity, and availability of their data on cloud. You can, continue to use the conventional security and, compliance concepts in cloud as well, and build a set of security policies and processes for your organization, as we discussed in the earlier slides. One of the recommended approach is to secure the perimeter. You can use VPC, you can use network ACLs, firewalls, subnets, and you can use a combination of these services as well to create a layered network security solution. And this acts as a first line of defense and ensure that the entry points are well secured. Now, all cloud providers provide key management services for data encryption, for encrypting the cloud services, even encrypting the cloud applications. And there are multiple options available to manage your master key pair. And it does have an abstraction for regions, meaning you can use set of keys for one particular cloud region and use the same for all the services in that region. It is recommended to use access management for user groups instead of an individual long list of users. Mustafa spoke about it, where it helps in scaling better. It also provides efficient way to update your access control list for large number of users or object at once in one go. You can build and test a pre-configured image to meet your security requirement. Let's say, AMI in case of AWS. All the best practices like, your root key access, API access keys, your secret keys, your password, your rotating credentials, all of that you can incorporate it as a part of image, harden that, and reuse this for seamless implementation of security guidelines across the organization. For application security, you can use, Windows firewall, web access control lists to help minimize the effect of distributed denial of service attack. For additional protection, you could use tools like AWS Shield Standard or AWS Shield Advanced, Guard Duty Inspector. I think Mustafa spoke about it. On Azure side, Azure Firewall, Azure also has a WAF feature, Azure DDoS protection. So some of the tools which cloud providers are suggesting are good to use to secure the application. Now, most of the applications are using third-party libraries, and this we have seen in many of our experience that becomes a miss, where these third-party libraries are either open source code or libraries, and it is important to analyze every piece of this code and make sure that it does not exposes any vulnerability. And we can integrate these third-party application scanning tools with our DevOps CI/CD pipeline. Some of the tools like Black Duck, White Hat, or Checkmark that we have seen in our engagements can be used here. Now, as a best practice, one should not provide the credentials, database credentials, or access keys directly into your application. You can use vaults, secret managers, etc., to store such sensitive configuration information, and provide it to the application during the runtime. We have been working with a client where we are integrating the HashiCorp vault for our deployments. And we are using Python SDK to query these vaults at runtime to retrieve these credentials. This also makes it easier to rotate credentials without worrying about the application configuration. In terms of storage, cloud storage are designed to provide high-line availability and durability. Also, it regularly verifies the integrity of data. If they detect corruption, they repair it, using the redundant data. Further, let's say Amazon S3, right, provides versioning. You can use versioning to preserve, retrieve, and store your objects on an S3 bucket, and it helps in recovering any unintended user actions or any application failure. This is a brief summary on some of the cloud security best practices. Now, let me go over briefly on our DevOps competencies as in practice. So, we work with Fortune 500 enterprises and help them in their digital transformation journey. We offer focused services on cloud and big data enablement, data lake implementation and management, solution engineering, and this is being supported by two of our world-class solutions. One, which is a data modernization platform for automated workload transformation, and two, Stream Analytics, which is a self-service data flow and analytics engine. And DevOps, acts like a center of excellence here, where we, leverage some of our subject matter expertise these engagements. As you can see on the slide, we provide in the center of the slide. If you see, we start from a bottom, which is the cloud infrastructure management services for all popular cloud providers, AWS, Azure, and GCP. We provide platform management services for big data and cloud platforms. This includes cluster administration, management, their monitoring, security, etc. We provide application management and support services. Applications can be a big data application or a cloud application, or for that matter, even Java applications. On the left is our continuous delivery service, which cuts through all of these services in the middle. Now, we enable our customers to accelerate the software delivery via infrastructure, platform, and application automation. And we enable the continuous delivery through deployment automation tools like Chef, Puppet, Ansible, Terraform, Python, and then integrate these with CI jobs along with the cloud containerization services, applications based on microservices and Docker, and finally deploying on various environments, dev, stage, pre-prod, prod, with single click. These environments can be on-prem, it's a purely cloud environment, or a hybrid environment, or a multi-cloud environment, or for a matter of fact, even Kubernetes environments as well. On the extreme right, we look at process maturity on incident change and problem management, developing operational dashboards for stakeholders for decision making, measurement and compliance to SLAs, and enabling Agile DevOps with Scrum, Kanban, and Scale Agile framework, which is SAFe. To get more details, please visit our website for a lot of these case studies which we spoke about. A lot of examples, details are available, and it covers areas other than cloud security like CI/CD, infrastructure automation, and all the other services. I really invite all of you to visit our website. That is all that I plan to cover today. Hope you find it useful. Thank you for your time, and over to you, Larry.
Thank you, Shirish and Mustafa, for a very comprehensive view of our topic today. What I would like to do now, and both Shirish and Mustafa will stick with us here as we move into our question and answer portion. What you will, however, see on your screen right now are a couple of final polls. The first says, would you be interested in a follow-up discussion as the capabilities as shown in the webinar? This is a great opportunity for us to reach out and literally put together a customized version of this in a walkthrough and a discussion of these topics as they relate to where you're at in your journey, which of the public cloud providers you're working with, et cetera, any special issues that you have. And if you indicate your interest in that, we'll be happy to follow up with you and make sure that we are able to do that for you. We ask you to rate your webinar experience, 5 being the highest. Very, very important that we get feedback on your user experience today. Also here where it says comments and feedback, that's a great opportunity for you also to provide us with feedback on how we can improve the user experience for other attendees at future webinars. So thank you again for all of that. We are going to move now to the question and answer session. You also see here on the screen our website and also being able to reach us through inquiry@impetus.com. One of the things we do offer there, if you have colleagues who had wanted to see this today but were not able to attend, or now that you've seen the material, maybe others who were not registered but would like to see this material on our website, in addition to the white papers and case studies and artifacts that Shirish pointed to, blogs and so forth. We also have a complete archive, which would include an on-demand version of this same webinar. So at this point, let me move us over to the Q&A portion. I see we've got some good questions coming in. And Shirish, I'd ask you to take this first one. The first question says, how do you protect data loss when using cloud storage? Shirish, if you would step up and answer that.
Sure, Larry. Excellent question. I think, the cloud is designed to provide resilience and availability, which means the objects that we store are redundantly, stored on multiple devices across multiple regions. Cloud providers, also regularly verify the integrity of the stored data. And I think, as I mentioned earlier, even they auto repair in case of data corruption. Now, another way that I can think of to strengthen data protection is by using versioning. Now, versioning lets you smoothly recover from the application failures. You can further protect versions by enabling specific features like, from S3, one of the features I can recall is MFA delete, which requires additional authentication and adds an extra layer of security. If you are concerned about your application software, or users might erroneously delete or overwrite objects, you can also specify a retention period for a bucket. So objects in this bucket will not be deleted or overwritten for a specified time period. And that can help you save the loss data loss. Additionally, you can place an object on hold, which prevents users from deleting or overwriting them until the hold is lifted. Azure, also provides the soft delete functionality that does not delete data from their storages, even if we do a delete at the storage level. I think these are some of the ways that we could provide data loss on cloud. Hope that answered the question.
Excellent.
Thank you.
Very, very useful. We've got another question that just came in. I'll read it. I think Mustafa, you may be the one to answer this, but if not, Shirish, you jump in. How do you move an application that needs to be PCI compliant on AWS? AWS infrastructure is PCI compliant, but what about getting some other noise in the background there, guys? Somebody may need to go on mute. The Amazon infrastructure is PCI compliant, but what about the card data? And Mustafa, would you like to take that?
Yeah. Hey, yeah, hi, Larry. So this is kind of a question that we have heard from a lot of our finance customers where they store data in terms of credit cards and also a lot of customers where they store SSN numbers and other PII data. So cloud would provide a lot of means to encrypt the data when you are moving it to the cloud. So you can use the cloud-based encryption while storing your data. You can use SSL TLS while making sure that the data transfer is secure. But if you want to make sure that all the PII, PCI data is also secured when it is actually stored in the cloud, so for that, there are a lot of tools like Voltage Secure, DataGuiz. So we recommend that the application itself should use these tools and encrypt the data onto the cloud. And when the people who are who wants to access the data, who have authority, they can use those tools again to decrypt that data and get the results. So we implemented similar such for one of the insurance providers while we were setting up the AWS data lake. So we did use cloud encryption, but for all PII, SPI field, we use Voltage to secure, encrypt the data while it is being stored onto the cloud, and then again decrypt the data while we are doing our data analytics. Analysts are using that data for further analysis. So I think that is how we can deal with all this PII, SPI data.
Okay, excellent. Mustafa, since you've got the mic there, let me direct this next one to you also. And it says, what are VPC endpoints? How do they help in security, and is it available for specific services?
Right, and again, that is kind of a very good question, because we covered that the virtual private cloud would abstract all the cloud resources within cloud in a user-defined network. But when we are using services like queue services, when we are using streaming services like Kinesis, so when we are sending data, even though from within our VPC, but because these endpoints are public, our data goes via internet to each of these services. Now, because of compliance issues, we might not want our data to go outside our VPC. In that case, VPC endpoints are used. So VPC endpoints, they're also called private virtual endpoints in Azure. What they do is that they provide us an endpoint within the VPC for these services so that our cloud resources can directly talk to these services without going to the internet. For example, if I have a queue and I want to send certain data from an EC2 instance from the VPC itself, so we can use the VPC endpoint that will make sure that the data transfer is also secure. Similarly, we can have VPC endpoints for a lot of other services as well.
Okay, excellent. Here's another question, and this may be for you, Mustafa, also. How can we implement security in serverless applications using Lambda or similar services?
Right. So serverless applications are kind of means of in today's world, people are using it for rapid development. It provides us infinite scalability. At the same time, it also provides us some of the security challenges. So since the serverless applications are mostly used for event-based development, they can be triggered by an API, they can be triggered by a storage event, they can be triggered by an event published in a queue. So the area of surface is too wide for any security tool to cover it. Moreover, since there are no infrastructure available for these services, the existing traditional agent-based security tools cannot be used in these cases. So the cloud providers have come up with a solution in terms of Windows application firewall, which helps in securing these serverless applications. These firewall sits between your application and the end user. So any communication, any request coming from the end user goes via these tools, and these tools can check for a lot of incoming user defined as well as default managed rules by the cloud provider, like SQL injection, threat protection, IP whitelisting, uh, cross-site scripting. So whenever a rule is satisfied, then only that request is forwarded to the actual application, which could be a CloudFront or an application load balancer, which then actually triggers the Lambda sitting behind the load balancer. So this is an kind of most popular way used by cloud services to secure their serverless application.
Excellent. Thank you. Thank you again, Mustafa. It looks like most of the questions have been answered. I want to thank our audience for being with us today. Remind you, as shown here on the screen, that we would love to hear from you if there are things we can do that to help you in your cloud deployment. If there are questions that you have that were not addressed today, or things that were addressed but you'd like some clarification, and again, indicate if you'd like some follow-up and more of a deep dive or customized version of this. But that does conclude our webinar for today. Thank you to our attendees and to Shirish and Mustafa, and hope you all have a great remainder of your day.